Hello students and welcome to the next part of data structure lecture series. In this portion we are going to study something about algorithms and its characteristics. As everybody is aware, what exactly an algorithm is? An algorithm is a well-defined list of steps for solving a particular problem. Now to illustrate this concept, let me give you a simple example. Let us just take an example where we have an array present with us. Let us assume the size of array as 10. In this 10 sized array, random numbers are present. Now I simply want to see whether some x is present in that numbers or not. So if, for example, I have an array of size 10 containing 10 different random numbers, and I simply want to see whether 25, the number 25 is present in that series of numbers or the array of numbers or not. So normally what is the procedure? The procedure is to look for 25 one by one in each and every array content. Correct? Now the problem is to be understood first. What do I have in hand is my input. What I want is my output. Now to get what I want to achieve, I will be using or I will be performing some steps. Those list of steps, those finite definite steps collection is called as an algorithm. Now how exactly we search a number in an array? It is extremely simple. I will simply search each and every element and equate that number with 25. That is a number to be searched. Whether the element present in first location is 25. If it is yes, then I will stop search at that point and I will display a message that yes, 25 is found. If the first number present in an array is not 25, then I will proceed. I will compare 25 with second number. If it is not, I will compare 25 with third number. If it is not, I will compare 25 with next number. I will repeat this process until my array gets over or 25 gets found. In both the cases, if 25 is found, then I will stop my search, or if array size exceeds or the 10 elements I have searched and 25 is not found, in that case I will be stopping at that point. So this complete set of sequence to solve a particular problem is known as an algorithm. This simple algorithm was for a linear search to find out an element, whether that element is present in your array or not. Now if I want to implement this algorithm, what exactly I need to have? I need to have, first thing, I need to have an array containing random numbers. Correct? What I need to have? I need to have a number to be searched. That means whether that number is present in that random number sequence or not. And third, what I am expecting as an output? I am expecting whether 25 is or the number to be searched is present in that list or not. If it is present, then it should display a message that yes, the number to be searched is present. If it is not present, then it should display the number to be searched is not present. In either case, I simply want the output in this manner. Now while performing these operations, what did I do? I simply perform a set of operation in a particular sequence. What sequence did I follow? I compared my number to be searched with each and every number starting from 0th index. Correct? I could have started it from the last index. I could have started it from the middle element or any of the element. But then the process of searching will not be fruitful. Correct? Let me give you a very general example. Normally at home in kitchen, if you want to cook something and if you are not able to find the ingredient, what exactly you do? You simply open each and every container present in front of you one by one. Let us simply say you want to cook a khichdi, and to cook a khichdi you are not able to find whether which container contains a dal. Correct? So what exactly you do? You find a complete array, a complete row of the containers present in your rack. You open each and every container one by one. Whether the first container contains a dal? No, it does not. Then you check for a second whether this contains a dal. No. Then another, and then another. The moment you find a container containing a dal, you stop your search. You don't go for next element. Correct? Or otherwise, in other words, you search completely. You complete searching each and every container present on the rack, and if you don't find a dal, you simply declare that the dal's container is not found in my house, so I will not be preparing a khichdi today. Correct? So in both ways you perform this thing. Now while performing this thing, if you start searching randomly, then that randomization will provide may or may not provide the effective results every time. Correct? So what is the proper way of doing it? You just go sequentially. Look for the first one, then go for the second one, then go for the third one, and then next, and then likewise. So a sequence or a way of performing or way of solving a problem is more important. Correct? Then likewise, based on this, the characteristics of algorithms are defined. The things which we are discussing right now are nothing but the basics for understanding the characteristics of an algorithm. Now, what exact characteristics should algorithm have? The algorithm should have 5 major characteristics. And which are they? The very first characteristic is your algorithm should be input specified. That simply means the input which is given to your algorithm to solve a particular problem, it should be well defined. The size should be well defined. The manner in which it is given should be well defined. If the input is not well defined, then the expectation of an effective result is not worthwhile. Correct? So the very first requirement for an effective execution of an algorithm is specified form of an input. What is the another characteristic or a second characteristic which we are going to deal with? That is output specified. Just like an input specification, you need to have a clear, concise and perfect idea in what form, what format, in what type, in what sequence you want an output. If this thing is not clear with you, then converting that algorithm to a executable program or an executable code and then effectively executing that algorithm or a code is not worthwhile. You have to be precise while dealing with your output specifications. Whether you want output in text manner, whether you want output in numbers, whether you want output in some structured manner, whether you want output in some another way, whether you want that thing to be given to some driver and to get it printed out or so to get it displayed, or you want to work with files, you want to update something, those all things should be specifically understood and specifically decided first. Unless and until you decide the form and format of output, the algorithm will not work well. The third most important criteria which algorithm should have is definiteness. Definiteness means every instruction in your algorithm should have a definite working area. That simply means you cannot write some random code to execute or to perform the task which is required to be solved by you. So each and every instruction should perform some definite operation. The next major characteristic is finiteness. The finiteness is called as a major characteristic because your algorithm, whatever problem you are solving for it, that algorithm should be finite. That means it should terminate somewhere. It should not be the case that you are searching for something indefinitely. The loop which you are searching in goes on and on and on. It should not be the case. Your algorithm should terminate somewhere, either giving a result, a favorable result, or giving an unfavorable result. But your algorithm should terminate. If your algorithm does not terminate, if it does not give you a result, then effectivity of that algorithm is zero. Correct? So your finiteness is more important than any of the algorithm characteristic that we have seen. And the last thing is effectiveness. Whatever characteristics we have seen, whatever instructions we have written for that algorithm execution, those instructions should be effectively followed, or those instructions should be effective. That simply means if you are writing a code for generating a calculator application which will perform addition, subtraction, multiplication and division on some random numbers or some rational numbers, then the instruction, each and every instruction which you write, it should be effective. If the instructions which you write are not effective, then it will hamper the efficiency or an effectiveness of a program. Now the basic question is how effectiveness of a program is calculated. Now this question we will be taking in consideration in our next topic. The effectiveness of an algorithm is majorly based on two things. First is the time required for its execution, and second, the memory space it takes for its execution. the effectiveness is measured in terms of algorithm's complexity. What is exactly a complexity? A complexity of an algorithm is a function which gives a running time or a running space in terms of input size. That means whatever input you have given, with respect to input, how much running time or how much running space it has consumed, that is called as a complexity of an algorithm. And based on the algorithm complexity, we decide the effectiveness of that algorithm. So just to sum up these things, what exactly an algorithm should have? Algorithm should be an input specified, it should be output specified, it should be definite, it should be finite, and it should be effective. Let us go in depth what exactly these concepts mean. Now, while discussing this input specified and output specified thing, the input precision requires you that you should know what kind of data, how much of data, and what form of data is to be used. Let us simply say that you are developing an application for a big firm, for a big company. Now, being a developer, you normally tend to work in a group where your project is divided in various different modules, and in most of the cases, you confine yourself to the development of some particular module only. You are aware about the inputs and output of other modules, but not the functionality of that. So you have to define, design, and declare your own module with respect to the input which is provided to you. If the input provided to you for your project is not proper, then the module you develop will not be a proper thing. Correct? So for that, you should know about what kind of data, how much of data, and what form of data is to be used. So this is the most important thing while implementing or while studying the characteristics of algorithm. The same thing, that is the form of data, the kind of data, how much of data, and which form of data is to be used. This precision is also required in output also. Now, apart from these two, algorithm must specify each and every step and the order of steps, that is the sequence of process. Correct? And the details of each steps must be spelled out, including all errors, of course probable errors. Now this is called as a definiteness. Correct? Now why exactly this thing is important? Let us simply say that you are writing a complete 300-400 lines of a code for a particular XYZ module, and in some line number 17, 79 or 80, your algorithm stops because of some error. And that might be a case, it might be because of you moved out of a loop, or you by mistake divided your input by 0, or any other. But what exactly happens when an error occurs? The execution of your program stops exactly at that point only. Correct? In some cases, you don't want your execution to be stopped. You want that if an error occurs, then your execution should get bifurcated, or your execution should get diverted to an error handling portion, and then the normal execution of your rest of the program should follow. This is called as exception handling. In most cases, object-oriented programming languages like C++ or Java, which are included in your syllabus in upcoming semesters, they tend to be working with these exception handling techniques. That means you go for a probable error. If that error occurs, then what should be done? You write a code for it. If that error does not happen, then the normal routine sequence of execution goes on. So, but before that, this should be declared, this should be defined in algorithm itself. Correct? It should not be the case that an error occurs, then you stop the algorithm, then you do something for it, then you again try and execute the same thing. So that is not advisable. Apart from that, while defining an algorithm, while designing an algorithm, you should be clear about each and every step which you are performing. You should be clear about the sequence of each and every step which you are getting. You should be clear about the exact core which you are going to perform and what logic it is going to implement. To implement that logic, the graphical representation of your complete problem solution should be present in front of you. It might be a UML diagram, it might be a class diagram, it might be a simple flow chart, might be. But the complete idea should be clear in your mind for a definiteness. If that idea, that means a sequence of process, each and every step's execution is not clear in your mind, then the algorithm will not be effective, and the program which is generated based on that algorithm will not be effective. And if program is not effective, then you will not get a desired output. Hence, eventually your program will be failed. Correct? So this definiteness plays a vital role in your algorithm characteristics. Then finiteness, that simply means your algorithm should stop eventually. At some point or the other, your algorithm should stop. If your algorithm does not stop, that simply means it does not give result. And if it does not give result, that simply means it is useless. Correct? So your algorithm must stop eventually at some point. And the last point says, for an algorithm to be effective, it means that all these steps which are required to get must be doable. It should not be the case that some things are taken as they are, or some things are just simply assumed. Whatever logic you implement, it should be doable. It should be it should be able to give you some output after some operation. If the operation which you are working on data does not give you a result, or that operation is not doable, then that algorithm has no efficiency at all, or the algorithm has no effectiveness at all. Correct? So while discussing algorithms, these 5 characteristics, which 5 characteristics? These 5: input specifiedness, output specificness, definiteness, effectiveness, and finiteness. These 5 characteristics plays a vital role. Apart from these 5 characteristics, there are various other characteristics which an algorithm should possess. Which exactly are those characteristics? These are the characteristics which your algorithm should possess. The first characteristic is your algorithm should be general and be applicable to several cases. Mind well, this slide contains all those characteristics of algorithm which are mostly used in object-oriented format. Now, while designing a bigger system, we tend to use object-oriented format rather than your procedural-oriented or block structured-oriented format. Why is that so? That will be clear when you start learning your Java more effectively. But before that, let me tell you, while developing some code or while developing a complete project, the complete project is divided in some various modules. The complete project is divided in various small effective functionalities, and those different effective functionalities are developed one by one. The dependencies are generated based on these functionalities, that what after this which functionality should be performed, for performance of some XYZ functionality, which resources are required, who contains those resources, how to get those resources, how to work with various different functionalities based on the dependencies which are provided previously. All those things come in mostly in object-oriented analysis and design. You will be learning those things in upcoming semesters. But while designing such type of algorithms as well, the algorithm should be general. That simply means whatever type of data you need to perform, whatever type of output you need to generate, your algorithm should not be data specific. Your algorithm should be process specific. For simple implementation, let me tell you, if you are writing a code for searching a number in a block of 10 integers, if you are writing an algorithm to search a number in an array of 10 integers, then your algorithm should be so general that even if you change the type of data, even if you change the size of your array, then that algorithm should be implementable. For float, that algorithm should work. For double, that algorithm should work. For size 100 array, it should work. For size 1000 array, it should work. So that simply means your algorithm should not be data specific, it should be a process oriented or a process specific. That is what I mean by algorithm should be general. Correct? The second point says the algorithm should be resource efficiently, should use resource efficiently. Now mainly your algorithm or any program uses 2 resources. Which resources it uses? We analyze an algorithm based on 2 things. That is how much time it takes and how much memory it uses. Correct? How much time it takes is called as a time complexity. How much memory it uses is called as a space complexity, roughly. Now based on this thing, time and space, we find out the resource efficiency of an algorithm. That means your algorithm should be resource efficient. It should be consuming minimum time. It should be consuming minimum memory space. It might be a case that for searching an element in an array of size 10, you might have various different logics. and to implement those various different logic, you implement various different algorithms. It might be a case. Some XYZ logic might take 5 units of time. Some XYZ algorithm might take 2 units of time. So whichever algorithm which takes minimum amount of time, that algorithm is supposed to be effective algorithm. The algorithm which takes maximum amount of time, that algorithm is not supposed to be effective enough. The same is the case with disk space. That is, your algorithm should take minimum disk space while implementing an algorithm. By disk space, I does not mean the size of your program file. By disk space, I mean the number of register it uses while performing internal calculations. It should perform minimum internal calculations. That is what I mean by disk space. Correct? The next characteristic, which mostly is advisable, not mandatory. The mandatory characteristics were previous 5. Now another advisable characteristic is your algorithm should be understandable. Now algorithm is something which is very general thing. Correct? It is not exactly a program. It does not provide you the executional details of your problem solution. Correct? Your algorithm is simply a sequence of steps to implement your logic to solve a particular problem. Is it not? Now if algorithm is simply a sequence of steps to solve a particular problem, then it should be so simple that it should be understandable by any layman. Correct? If the algorithm itself is not understandable, then the developers who try to develop that algorithm will find it difficult. And if you find your algorithm difficult, then the writing code or providing the logic or implementational logic for that algorithm is extremely difficult. So your algorithm should be understandable so that the operations are clear for each and every reader. The next algorithm property which is advised is algorithm should be clear and precise. That simply means your algorithm should not be taking some ways or some paths which are not at all required by a program. Correct? By this thing I mean, in most of the cases we try to implement something by implementing or by using various different things which are not at all required. Say for example, if I want to convert some floating point value to an integer value or some integer value to floating point value, then that conversion is extremely simple if you typecast those things. Correct? Other than typecasting is the very simple, very effective thing. Other than those things, there are various functions, library functions which can be used to perform these things. So these things are not clear and precise. Correct? So in most of the data structure which we will be seeing in upcoming lectures series, that there are various ways to solve some particular problem. You have to select a very clear and very precise way so that the analysis process of that algorithm becomes simpler. The next advisable characteristic is your algorithm can be specified at different level of details. That simply means your algorithm can be modified or can be extended for implementing various different level of details as well. Algorithms always build on functionality previously defined known to the users. That simply means if you have a complete library set present with you, then your algorithm should use those library set rather than giving entirely functionality from scratch. That simply means if you have quicksort function present in your library, then you should not waste time sorting the complete array. You should proceed with the actual implementable logic whether that sorted array is required. Correct? So if you have algorithms which are already present in your library, then your new algorithm for which you are designing to solve a problem, that should be based on the previously defined algorithms or the library functions which are provided to you. So these characteristics are advisable characteristics which your algorithm should have. They are not at all mandatory, but they should be there if you are writing your algorithm. But the mandatory characteristics are your input, output, definiteness, finiteness and effectiveness. Correct? Now let us just talk about effectivity of an algorithm. If I have been given two algorithms at a task, then how do we find out which one is better? Now this task is quite tiresome. Let us just say include some logical understanding of a problem. Let us simply say that I have given you a simple sorting algorithm or a simple element searching algorithm, correct? A linear search algorithm will do. I am implementing that linear search algorithm which search the search key with each and every element present in your array sequentially. I am implementing that algorithm in dual core processor, and I am implementing the same algorithm in your i7 processor. So what do you think? In which case it will work faster? It will work faster in i7 processor, correct? And why is that so? Because of some internal architectural changes. Sure, but does that mean I have changed my algorithm? No, I have not changed my algorithm. So that simply means your time required to execute an algorithm with respect to seconds, milliseconds, that should not be the key for analyzing the algorithm. Then how should we check for effectiveness of an algorithm? How should we check the time? So the unit of time should be based on number of operations performed. In same way, if I want to check how many memory spaces it takes or how many block of memory it uses, then your algorithm's efficiency with respect to memory should be checked with respect to the amount of memory it has consumed, correct? The amount of time the algorithm has consumed with respect to operation and the amount of memory which your algorithm uses with respect to operation. These two things define the complexity of an algorithm, and complexity of an algorithm is a major term for which based on which we perform the analysis of algorithms. Now why exactly this analysis is required? That this question. Then how do we analyze different algorithms? This one. And what exactly is the process of analysis of an algorithm? That we will be seeing in our next portion of lecture. So right now, let us just summarize, let us just review what exactly we have seen. We have seen the definition of algorithm, what exactly an algorithm is. Then we have seen 5 important characteristics of algorithm. After seeing the 5 important characteristics of algorithm, we have seen the general characteristics of algorithm, that is the advisable characteristics of algorithm which your algorithm should have. And we are concluding on a question that how exactly do we analyze two algorithms, how exactly do we decide that which algorithm is best, correct? So right now we will be stopping at this point. We will be starting our discussion with analysis of algorithm in next video part. Thank you for patiently listening to it.